JUICE was using its main high-gain antenna while still heading toward Jupiter. The spacecraft was about 66 million kilometers from the comet on November 2, 2025, 2 days before closest approach, but the geometry was perfect for catching dust and gas escaping from the nucleus. During the flyby window, JUICE spacecraft had 5 science systems powered on. All of them were pointed at 3I Atlas to take advantage of the comet's state just after perihelion. Cropped navigation camera frame revealed a thick cloud of gas around its nucleus and a distinct plasma tail, both signs of strong heating and active release of material. The comet carries ingredients sturdy enough to survive long travel and still be released in measurable amounts. The faint dust trail, extending downward, grains large enough to resist sunlight pressure, giving researchers a direct clue about their durability. Similar grains retrieved from the earlier Stardust mission around Comet 81P Wild 2 formed at extremely low temperatures, near 30 Kelvin. This points to 3I Atlas as a carrier of solids shaped in cold and dense cloud regions, far from any star, the kind of places where many earlier building blocks of planets are thought to form. But did it deliver nothing beyond frozen gases? Telescopes detected carbon monoxide signals that point to active chemical breakdown and not just passive evaporation on the comet. Light curve measurements from October 2025 show the nucleus rotating with a wobble. Even so, the team decided to risk pulling down a tiny fraction of a single frame from the navigation camera. The camera of JUICE itself is not a science instrument. It is meant for tracking icy moons once JUICE reaches Jupiter in 2031.